Now moving ahead, we see this particular question in here. It says that a cylindrical conductor of length L and uniform area of cross section A has resistance R. Okay, this wire with the length L and resistance R. Area is given as A. Then another conductor of length 2L, there is another conductor whose length is given as 2L and resistance R. There is another wire whose resistance, and this is given, of the same material must have the cross section. What should be the area of cross section? That means both of them should have the same resistance. Then what should be the area of this? Because it is L upon A, that means the area should be 2A, so that this A and this A should get cancelled and they both become same. So the answer here will be 2A. Moving ahead to the next question, it says that a resistor and key and ammeter are arranged in here. The current recorded in the ammeter will be, the current recorded in the ammeter, if you see, but there's one resistance, and there's only one resistance and one battery, one voltage and one voltage is there. So it is going to be same in all the three circuits. Moving ahead, it is given that a current of 1 ampere is drawn by a filament of the electric bulb. Number of electrons, okay, 1 ampere is the current that is flowing, I is equal to 1 ampere. Okay, the number of electrons passing, number of electrons is given by the formula N is equal to Q upon E is the formula. Okay, that is given to me. Then first, then it says passing through the cross section of the filament in 16 seconds would be roughly, the time is given to me as 16 seconds. Okay, so the charge is equal to I into T, right? The charge is equal to this. So I is given as 1 and the time is given as 16. So it is going to be 16 coulombs of charges are flowing. When I have 16 coulombs of charges flowing, the number of electrons that is flowing is 1.6 into 10 to the power of minus 19 coulombs of electrons are flowing. So if this is negative power, when it comes over at the top, what is going to happen? This negative power becomes 10 to the power positive 19. So how many do I have? Positive 19. Which one is near to positive 19? And 16 is here. Okay, so it is approximately considered to be this. You cannot go less. You could have taken 18 also, but we cannot take less. It is already 19, so 19 and above will be there. So 10 to the power of 20 will be the answer here. The next one, it says that in the following circuits, heat produced in the resistor or combination of resistors connected to a battery will be, there is one circuit, one resistor. This is series. This is the parallel resistor. Same in all the three cases? No, because only one resistor, two resistors and parallel resistors are there. So this resistance is not the same. I mean, heat produced will not be the same. Okay, it will be maximum in this particular case because these are connected in parallel. The parallel connection has more heat dissipated through it. Okay, next, and the student carries out an experiment where this is given, and we know that this one will have the highest resistance than this one, so it should be R3 and R1 in the end. R3 and R1, this is the option, that is what I'm going to mark here. Next is, it says that out of the three bulbs, 25 watt, 60 watt and 100 watt, which bulb has the least resistance is what they're asking. So least resistance means the bulbs are the same size, only the wattage is different, and the wattage is the least, the resistance is least in the highest wattage ones. Okay, moving ahead, in an electrical circuit, two resistances 2 and 4 ohm respectively are connected in series in a 6-volt battery. Okay, fine. The heat dissipated by the 4 ohm resistor in 5 seconds will be, okay, fine. So for heat dissipated, the formula is heat is equal to P into T. Now P is taken as VI into T. T I know it is already 5, so into 5. Now VI, do I know the voltage? No, I do not know the voltage because these are connected in series. The voltage remains the same. Voltage will be changing in both of them, so we will take the current formula here. So it becomes I square R into T. Okay, why? Because V is equal to IR. This IR into this I square R it becomes, and then the resistances will be, it is 6 ohms of resistance. Do I have the current? I don't have the current also. So V is equal to IR. V is 6, R is also 6. So I is equal to 1 ampere. Okay, so here it becomes, in place of this, I'm going to write 1 into R is 6 into 5. Okay, so no, R is now among the 4 ohm resistor is asking. So this 4. 1 is for the current, R is for the resistance, and 5 ohm is for the time. So 1 into 4 is 20. So 20 joules of voltage is flowing, joules of heat is dissipated. What is the maximum resistance which can be made using 5 resistors, each of 1 upon 5 ohms? Okay, so if you look at this particular question, 1 upon 5 resistors are there of 1.5 ohms. So this and this gets cancelled. So 1 ohm is the maximum that you can make out of it. Okay, now these are the questions that you will be having. Now moving ahead, it says that draw a circuit diagram of an electrical circuit containing a key, an ammeter, and a resistor. So fine, he said a key is there. So there will be a voltage cell, and then there is going to be some amount of key attached here to it. And then it says that there's an ammeter. I can keep the ammeter here, and then I have a resistor in series. A resistor is there in series, and then with series with a combination of resistor, there is a combination of resistors, 4 each in parallel, and a voltmeter across the parallel combination. Okay, 4 resistors are going like this, and then there is a resistor voltmeter connected in parallel. So the voltmeter has to go in parallel to this one. Okay, to this part only it is going, with the potential difference 2 across the resistor will be the same as that across this. Okay, so we have to create it such a way that the potential difference across this and this is going to remain the same, and this will be the final circuit. So 2 ohms goes here, 4 ohms goes here, 4 ohms go here, and then I have the positive to positive, negative to negative. So also the negative will be connected to the positive, and the positive will be connected to the negative in here. So the circuit will be completed. Now after this, we have questions. Would you write would you be reading what would be the reading of the ammeter and the voltmeter in the given circuit? First of all, the reading of the ammeter is going to, ammeter will be, first of all we need to calculate the series resistance, right? So series resistance is 3 ohms, and then the current in the circuit will be, voltage is given, resistance we know, current in the circuit is 1 ampere. The complete circuit current will remain 1 ampere only because this is a series. Okay, and then the voltmeter reading will be, voltmeter will be I into R. V is equal to IR. For the voltmeter, V is equal to IR. Some students voltmeter 3 volts only. No, that's wrong. V into IR, that is 2 into I is 1, that is equal to 2. 2 voltmeter reading will be there. Ammeter though, anyways, whatever the current is flowing in the circuit, that will only show here. Okay, the next question we have here, write down the relationship between the resistance and electrical resistivity. Resistance is equal to resistivity, L upon A is the formula that I have. Okay, then after that, the resistance of a metal wire 5 meters length is 100 ohms. Resistance of the wire is given as 100 ohms. Length is 5 meters. If the area of cross section of the wire area is given as 3 into 10 to the power of minus 7 meters square, calculate the resistivity. Rho is equal to RA upon L. That is 100 into 3 into 10 to the power of minus 7 upon 5. 5 ones are, 2s are, 0s are, 2 3s are 60. 60 into 10 to the power of minus 7 becomes 6 into 10 to the power of minus 6 ohm meter, or you can leave it ohm meter here also. This will be the valuation for it. The next is questions that we have is, yeah, what would be the values of, so going ahead with this part of the question, it says that Murat answers the piece of a wire of resistance 20 ohms. Okay, there's a piece of wire with resistance 20 ohms is already given to us, is drawn so that its length, okay, so he said so that it's drawn so that its length is increased to twice. There's a wire already, but it is further extended so that the length from L, it becomes 2L. Okay, then calculate the resistance. Whenever the wire's length is increased, there is same wire and I'm pulling it further so that the length increases, the original area reduces by 2. What happens to the area? The area reduces by 2. Now they give resistance is equal to this much. So that means R is equal to rho L upon A is the formula. 20 is equal to rho, L is L, and A is A only. After certain time, the length is increased. Okay, the length has become 2L and the area has become A by 2. So what is happening to the resistance they are saying? what will be the resistance? Because it is the same wire, will not consider the resistivity of this wire. Okay, and this is by 2, so when it goes up, it will automatically go up. It becomes 4L by A is equal to R. But I already know from this equation that 20 is equal to L by A. So instead of L by A, I will write 4 into 20 is equal to L is equal to the resistance. 4 into 20 becomes 80 will be the resistance of the new wire if the length is doubled and the area is reduced by 2. Okay, now the resistance of a metal wire 1 meter is 20. Okay, length is given as 1 meter, 20 R is given as 26 ohms. If the diameter of the wire, this is an NCERT question, they have given the diameter, they did not give the area. So you are going to find the area by pi r square formula, where pi is 22 by 7 and r square is 0.3 into 0.3. Okay, this is in mm. It has to be converted into meters. So into 10 to the power minus 4 into 10 to the power of minus 4. Because millimeters to meters, first it will go from millimeter to centimeter, multiply by 10, and then it will go to meters. So into 10 to the power 3. So total of 10 to the power minus 4 it becomes. Okay, so you simplify it, substitute it, and you get the value of the resistance in here. A resistance R is doubled on it. So calculate the resistance of the wire. A resistance 4 ohm resistance is doubled on it. Doubled on it means what is going to happen? The area has been doubled. Okay, the cross section, the area has been doubled. When the area doubles, the length is decreasing. Okay, so I understood if I'm increasing the length, the area reduces. But if I'm increasing the area, the length reduces. This is what is going to happen. Okay, so they are doing the same thing in here. Reducing, our rho gets cancelled, and when we are taking the ratio, it becomes 1 ohm will be the resistance for this one. C series and parallel combination of the resistances. A current of 1 ampere. First of all, is there anything? Nothing is given. Only 5 ohms is given here. Okay. A current of 1 ampere flows in the circuit having an electric lamp and a conductor of 5 ohms. Okay, conductor of 5 ohms is given. When connected to a 10 volt battery, calculate the resistance of the electric lamp. What is the resistance flowing? He said that a current of 1 ampere flows in the circuit. The current is given to me already. Current is equal to having electric lamp and a conductor of 5 ohms. Okay, the resistance is given as this. The electric lamp will also have a resistance is what we are seeing. Okay, so this is resistance and this is resistance. They both are in series. So this is R1 and R2. R1 plus R2 will be the total resistance in the circuit. Voltage is 10 volts is already given to me. So V is equal to IR is the formula. Voltage is 10 volts is equal to I. I is 1 into R. R becomes series of this. So R1 plus 5. R1 plus 5. So this becomes R1 plus 5 is equal to 10. I send it here. R1 is equal to 5 ohms. So the resistance, calculate the resistance of the electric lamp. We have calculated the resistance of the electric lamp. Now if the resistance of 10 ohm is connected in parallel, there is connected in parallel with the series combination, what change will happen? Now 10 with this series, there is another resistance that we are going to connect. They are saying, so these are in series. Then what is going to happen? First of all, the resistance will change. R1 plus R2 is equal to 5 plus 5, which is 10 ohms. Now this 10 ohm, they are in series again. So 1 by 10 plus 1 by 10, it becomes 2 by 10, which is equal to 1 by 5 ohms. So resistance, the parallel resistance will be 5 ohms. The total resistance that you will have in तीनों का मिला के will be 5 ohms. Okay, then what will happen? This is anyways 10 volts only. Current happening. Current is equal to V upon R, 10 upon 5. 2 amperes you will get. So the current is increasing if another resistance is added. Okay. And there will be no change in the potential difference across the lamp. Okay. Two resistors with resistance 5 and 10 ohm respectively are connected to a battery. 5 and 10 ohm are connected to a battery of 6 EMF battery. Find the minimum current. For minimum current, because they are in series 5 and 10, it will be total is 15. So current is equal to V upon R, that is 6 upon 15 you will get, which will be 0.4 amperes. This is the minimum current. Maximum current ke liye you will have to change them, because when it is in series resistances the current will flow same, but if they are in parallel then you will have a change in current. And for them to be parallel, 1 by 5 and 1 by 10 you are supposed to do here. Okay, take the LCM, find your R. 1 by R is this. Then you get your R value. They've done the same thing. They did it. They got the R value and they calculated the current. It is 1.8. Next we have, for a circuit in the following given diagram, current through 6 ohm resistance is there. This we have to find out current. First of all, they are in series. So we'll make the series. This is going to be one resistance of 9 ohm. Then this is going to be one resistance of 15 ohm. They both are in parallel to each other. So we'll make them 1 again. So 1 by 9 plus 1 by 15 I will do. Okay, 15 and 9 LCM 5 threes it will go 9. Then 3 ones are 3 ones it will become. Okay, 5 threes are 15, 15 threes are 45. Yeah. What is the value? What is the potential difference across the 12 ohm resistor? Current through this. They haven't done this. Why? I do not understand. They're just taking I is equal to 9. They're not even considering this part of the circuit for the first one. So we'll do the same thing here. I1 is equal to V upon R1. Voltage is 4. R is 9. So that turns out to be 0.44. Okay, and then we have R2. He's talking about the 12 ohm resistor. So the 12 ohm resistor is going to be V upon R2. So 2 upon the series current we are taking, 0.27 amperes is what you get. Then the potential difference across this. Potential difference is, because it is the I2 that is flowing here. So I2 into 12. I2 was how much? 0.27 into 12. That turns out to be your V1 value. Okay, that is the flowing through the circuit. Okay.